Hello, my name is Safwan, and today I'm going to talk about how I designed the mini projects from the scratch. So before we start building the mini project, we need to have the sketches. So in order to design the keychain, using the name of KKTM Ledang as the main font, I use Cattle.xyz as a web-based tool that allow me to choose and modify the design of the font itself. I adjusted the letter spacing, outline stroke, letter height, and also modified the width and height. I set the max of the width is 90 millimeters and the outline borders for the wall is 0.8 millimeters. These adjustments were made so to ensure there was enough space for the filament LED to sit and also for the electronic component. Once the design ready, I exported the file into the DXF file. The DXF file then imported into the Onshape, which is a 3D CAD software. I use the 3D CAD software Onshape to create the letter to become a 3D products. I also added a box to housing the PCB and also the battery holder. I create a 1mm thick face layer for the text, which will later be printed in with the white filament, so that allow the LED to pass through. And the outer part was extruded to 10mm and make it hollow inside, so the LED can pass through inside the letters. During this process, I faced some difficulties, which how to extrude the box that houses the components, which I want to make the box have different heights with the letters. So by using the offset tools and reverse the directions, I able to do it inside the extrude tools. After finishing the design in Onshape, I make sure the dimension follow through all the tolerance that have been stated in the task. Then we can move on to the PCB construction. In this task, we are assigned to fabricate PCBs with resistor and capacitor assemblies, which is 0806, which is 2mm width, and also a single electrolytic capacitor with have the distance of through hole is 8mm, and the box size with only 50mm by 30mm. I run a lot of difficulties when doing the task 2. First and foremost, the space of the border itself is way too small because the 8mm electrolytic capacitor is big, so it takes a lot of space. After that, there are also a 3 terminal junction were also big, so it's going to take a lot of space inside the board itself. So by utilize double layer PCB board, I'm able to route the copper routing properly and avoid any violations such as 90-degree routing path, which is not recommended in IPC standard. So before we can even start fabricate the PCB, we need to construct a schematic first. So I construct a schematic in ISIS Proteus, and after I've done construct it, I went to the Aris to design the PCB itself. After I've done design the PCBs, I go to the pre-production checks where they check all my routing and my component does not violate any rules or overlap each other. Then I can go to the output Gerber files to output my PCB to be Gerber file, so that I can send it to the manufacturer so they can build the PCB. But for this many projects, we don't have the tools to fabricate PCBs. Instead, our lecturers give the PCB itself. So this task this task need to do, but it just no need to be fabricated. Alright, lastly, we export the 3D file from the on-shape to XDL file. Then we're going to feed the XDL file into the Ultimaker Cura, which is a software that where the printer can read the scripts. So by import the XDL file into the Cura, I'm able to make a scripts. So for this one, for this particular task, I make sure the face of the product laid flat on the base, so that we can reduce the amount of support that we use, and also the mass and the time taken to build this 3D printing. And also I put a script where on the 5th layer the printing will automatically stop, so that we can put the white filament and then change it to another color, for example like purple or pink, so that we can have nice transition between white and pink. So also this also will help LED to be diffused better with white color compared to other colors, and can make it much more easier visible when the LED is turned on. So after done scripting then I export the file into the SD card. Then the SD card will fed into the 3D printing device, and then the 3D printing device will print the product itself. So after that, after all have done, so we go to the soldering and assembly, which is I solder the LEDs, the PCBs and the battery holder together and put it inside the kitchen itself. So first, there's a lot of problem that I face. First of all, the legs of the LED is way too fragile, where if you hold it for long enough, the leg may become brittle and can break easily. Second of all, I accidentally make the housing for the PCB a bit too small, so it's hard for me to adjust it, because the space of the housing itself is just enough to put battery holder and the PCB and do not have any wiggle room. And I think that's all from me. In the end, the project is successful. As around us here, as you can see, this project is still a successful despite every difficulties that I have faced. So I'm going to show you how the output will be. Yes, you can see it's light up a bit. Yeah, it's mainly due to the board itself or the soldering joint itself, but I don't want to touch it even further, because the more you touch it, the easier the filament like to be brittle. So I tend to not, because I already broke it 2 times. So yeah, this is the final product. That's all from me, Safwan. Thank you for watching and bye bye.